Boys and girls, corrections, question 5. We are given a diagram and information. BOE is a diameter, O is the center of circle, AD is perpendicular to BE but is not indicated on the diagram. I told you from the information, if something is mentioned and not indicated, we're going to indicate it on the diagram. These lines AD is perpendicular to BE. Those lines are perpendicular to each other. That means each angle around here is 90. Right, and then B2 is X. B2 is X. Let's indicate that this is X. B2 is X. Right, now, where do we start? Remember, I told you don't rush and satisfy a question by a question to get answers. No, we're going to start with what we know. We're going to indicate angles that are equal, anything that you know there about theorems. Now, when we check there, we have many angles equal there. A1 is equal to D1. Angles in the same segment. If you check, these angles are in the same segment, are subtended by the same arc BC. And then again, we can indicate angle B. The whole angle B1 plus B2 is equal to angle C. Remember, we are doing rough work. We are not answering any question here. Now, another thing, we can indicate that this angle A1 and A2 equal to angle E. These angles are in the same segment, are subtended by the same arc BCD. Subtended by the same arc. Angles in the same segment. Again, we can indicate this angle equal to B1. Angles in the same segment. Right. And then remember they said BOE is the diameter. Then now we know if diameter is drawn, then it subtends a 90 degrees angle. This angle is 90. It's 90 degrees. Angle in a semicircle. Right. I think this is enough about rough work. Then we can answer questions now. First question, prove B1 is equal to angle B2. Right. If you can see in the diagram there, angle B2 is not indicated the same as any other angle there. But angle B2 is equal to X. It means we're going to find other angles in terms of X until we arrive at B1 in terms of X. If you find B1 equal to X, then we conclude. Right, now we are required to prove this. Let's start. From the diagram, we can see in this triangle, we can find that angle in terms of X. In triangle BED. In triangle BED, B2 is equal to X. That one is given. And then angle BDE is equal to 90 degrees. What is the reason? Angle in half circle. Angle in a semicircle. Right, then from there we can use sum of angles of a triangle. In that triangle, B2, angle B2 plus angle DE, DB, BDE plus angle E equal to 180 degrees. The reason is sum angles in a triangle. Now, when we substitute angle B2, remember angle B2 is X, and then angle BDE is 90, and then angle E equal to 180. Then we're going to make angle E the subject of the formula. When we rearrange, angle E is equal to 90 minus X. Now, we found this angle. Now we found this angle. This angle now is 90 minus X. Right, but that angle is indicated the same as that other angle in there. Right, those angles are in the same segment, and this one, it connects with that angle. At the end, we're gonna find this angle in terms of X. Now, let's continue. Angle BAD is equal to angle E. What is the reason? Angles in the same segment. Angles in the same segment. These two angles are in the same segment. Right. And then, but in that triangle, let's have a look here. In triangle ABF. In triangle ABF, right, angle F1 is equal to 90. What is the reason? Remember from the statement they said angle AD is line AD is perpendicular to BE. AD perpendicular to BE. AD perpendicular to BE. F1 is equal to 90. Now we can use sum of angles of a triangle to find B1. Angle B1 plus angle F1 plus angle BAD equal to 180 degrees. Some angles in a triangle. Some angles in a triangle. Now we can substitute. Substitute 1B1. What is the size of F1? F1 is 90 plus what is the size of BAD? Remember, we said BAD is equal to E and angle E is 90 minus X. Now, in place of angle BAD, we can put 90 minus X. Right, from here, when we rearrange to make B1 subject of the formula, B1 is equal to X. Now we can conclude by saying, therefore, B1 is equal to B2. What is the reason? Each equal to X. Right. Now, someone can use another approach. I'm not going to write everything. Right. Remember, this is X. This is 90 minus X. And then someone can use triangle DFE. Triangle DFE. Remember, F3 is 90. Now, if F3 is 90, this whole triangle help us to determine 90 minus x is fine. Then now you're going to use this right angled triangle and find this angle highlighted in green equal to x by sum of angles of triangle DFE. If this is x, therefore that one is also x because they are indicated the same. Angles in the same segment. Then we can conclude by saying B1 is equal to B2, each one equal to x. The second question, prove angle ACD equal to 2x. Right, let's have a look on the diagram. ACD equal to 2x. Now, ACD is indicated the same as angle ABD by direct reason, and B1 we know is x and B2 is x. This one is very, very simple. Right, let's present it. Angle ABD. Angle ABD is equal to angle ACD. The reason is angles in the same segment. Angles in the same segment. Angle ABD is equal to 2x. Then we are done. Now the last question. Prove GCDO is a cyclic quadrilateral. Now, when we check on the diagram, GCDO, by the look of eye, is not a cyclic quadrilateral, but we're going to prove that it is a cyclic quadrilateral. Now, the question is, what do we look at to conclude, or what is needed for us to conclude that a quadrilateral is cyclic? Now, I have three properties here that we're going to use and conclude that a quadrilateral is cyclic. The first one, when we're given a quadrilateral and then one side is extended and we see that the exterior angle is equal to the interior opposite angle like this one. Now, if x is equal to y, if these two angles are equal, the exterior angle is equal to the interior opposite angle in that quadrilateral. Remember, it is not a cyclic quad, it's a quadrilateral. Now, we can conclude by saying that quadrilateral ABCD is a cyclic quadrilateral. What is the reason? How do we reason? We reason because of this. Converse exterior angle of a cyclic quad. Or we can say exterior angle of quadrilateral is equal to the interior opposite angle. Right, the second one. Now, when we see this situation, if this situation is satisfied, opposite angles, when we add those two opposite angles, add up to 180, then we can conclude by saying ABCD is a cyclic quad. How do we reason? Converse opposite angles of a cyclic quad. Or we can say opposite angles of quadrilateral are supplementary. Now, the last one. If a line subtend equal angles on the same side, if we have a line subtending equal angles on the same side, if y is equal to x, then we can conclude by saying ABCD is a cyclic quadrilateral. It means these 4 points are lying on the circle that we don't see there. Now, we can conclude by saying ABCD is a cyclic quad. What is the reason? Converse angles in the same segment, because we see the situation where angles are in the same segment equal. Is it clear? Right, then now, even if this line is not drawn, then if we see this situation, then we can say point A, B, C, D are concyclic, are lie on the circle that we don't see there. Therefore, A, B, C, D is a cyclic quad. Now let's prove GCDO a cyclic quad. Right, in the diagram here, GCDO, the way the diagram is like, you're going to think about which property can be satisfied. If you can see there, I think the first one is going to be satisfied, or the second one can be satisfied, but the last one cannot be satisfied because we don't have the diagram of this nature. If you can see there, we don't have the diagram of that nature. But now, we have one line extended, the exterior angle formed. If these two angles are equal at the end, therefore this is a cyclic quad. Now, let's start with that one. Right, intra-angle OED. Intra-angle ODE, this triangle OED. We can see that OE is equal to OD. What is the reason? Radii. OE equal to OD. Therefore, angle E is equal to angle D4. Each one will be equal to 90 minus x, because already we said E is equal to 90 minus x. We found this in terms of x in the previous question. What is the reason that those angles are equal? Angles opposite equal sides. Angles op equal sides. Angles opposite equal sides in a triangle are equal. Right, now we're going to find O2 by using sum of angles of a triangle. O2 plus angle E plus angle D4 equal to 180 degrees. What is the reason? Sum angles in a triangle. Some angles in a triangle. Then now let's substitute. We're going to substitute D. Remember, we want O2. We're going to substitute angle E. Plus angle E is 90 degrees minus x, and then also D4 is 90 degrees minus x plus 90 degrees minus x, which equal to 108. Then now we're going to make O2 the subject of the formula by rearranging. Now we're going to find 2x. Now, remember angle C, this angle. Remember angle C is equal to 2x. But angle C is 2x. Already we found it. Now, therefore, O2 is equal to angle C. Each equal to 2x. Then now we can conclude by saying, since O2 equal to angle C, therefore GCDO is a cyclic quadrilateral. It's a cyclic quad. What is the reason? You must give a reason. Because we saw this situation. we saw this situation. Exterior angle now, O2 is equal to C. Exterior angle, converse exterior angle of a cyclic quad. Please don't just say exterior angle of cyclic quad. That thing is not a cyclic quadrilateral. But now, by looking at something, because of this reason, we conclude is a cyclic quad. That's why we say converse. Don't just say exterior angle of cyclic quad. Otherwise, you are already saying it is a cyclic quad. Please be careful. That's how we prove that a quadrilateral is cyclic. Thank you. Right, someone can approach this differently to prove GCDO a cyclic quad to satisfy this second property, that opposite angles, the sum of opposite angles of that quadrilateral add up to 180. Now let's do it, but I'm not going to write everything. You're going to understand. 2x, remember this is 2x, C is 2x, ne? And then someone is going to find angle O1 in terms of x. You can use triangle OBD because OB is equal to OD. Then already this is x and that one is x. Then it means this angle, it will be 180 minus 2x. Find O1 in terms of x. Now, 180 minus 2x plus 2x give us 180. Now, the sum of these two is equal to 180. Then we conclude by saying GCDO is a cyclic quad. The reason is that converse opposite angles of a cyclic quad or opposite angles of quadrilateral are supplementary.